Let's look at the relations y is equal to e raised to the power minus 2x, y is equal to sine of e raised to the power x, and y is equal to cos of log x. Clearly, these are composed of exponential and logarithmic functions. To differentiate such relations, we use some basic formulae. The derivative of e raised to the power of x with respect to x is e raised to the power of x. In other words, the derivative of a natural exponential function is the function itself. The derivative of log x with respect to x is 1 divided by x. Let's apply these formulae to find the derivatives of the given relations. Observe that in each case, the given function is a function of a function. So, we will apply the chain rule while differentiating them. Let's begin with the first one. On differentiating both the sides with respect to x, we get dy by dx is equal to d by dx of e raised to the power minus 2x. By applying the chain rule, the right-hand side becomes e raised to the power minus 2x into d by dx of minus 2x. The derivative of minus 2x with respect to x is minus 2. Therefore, dy by dx is equal to minus 2 into e raised to the power minus 2x. Next, let's find the derivative of y is equal to sine of e raised to the power x. Differentiating both the sides with respect to x, we get dy by dx is equal to d by dx of sine of e raised to the power x. By applying the chain rule, the derivative of sine of e raised to the power x with respect to x is equal to cos of e raised to the power x into d by dx of e raised to the power x. The derivative of e raised to the power x with respect to x is e raised to the power x. Therefore, dy by dx is equal to e raised to the power x into cos of e raised to the power x. Lastly, differentiating both the sides of y is equal to cos of log x, we get dy by dx is equal to d by dx of cos of log x. By applying the chain rule, the right-hand side becomes minus sine of log x into d by dx of log x. The derivative of log x with respect to x is 1 divided by x. Therefore, dy by dx is equal to minus 1 divided by x into sine of log x. Many a times, we have to find the derivative of a function that is the power of another function. Such functions can be differentiated easily by applying logarithms on both sides. Taking logarithm of the function, we get log y is equal to v of x into log u of x. Now, the right-hand side obtained is the product of two functions, which can be solved easily by applying the product rule. On differentiating both the sides, we get d by dx of log y is equal to d by dx of v of x into log u of x. Now, by applying the chain rule, the derivative of log y with respect to x is 1 divided by y into dy by dx. Thus, the derivative of the right-hand side is equal to v of x into 1 divided by u of x into u dash of x plus v dash of x into log u of x. Therefore, the derivative of y with respect to x is as shown here. This process of differentiation is called logarithmic differentiation. Note that this method is applicable only if functions f of x and u of x are positive, because logarithms of negative quantities are not defined. Logarithmic differentiation can be applied to find the derivative of any complex function. Hence, we can say that logarithmic differentiation is a process by which a complex function can be differentiated by taking logarithm to base e of the function and then differentiating both the sides. Let's apply logarithmic differentiation to find the derivative of y is equal to sin x whole raised to the power log x. First, take logarithm to base e on both the sides. This gives log y is equal to log x into log of sin x. Next, differentiate both the sides with respect to x. This gives d by dx of log y is equal to d by dx of log x into log of sin x. By applying the chain rule, the derivative of log y with respect to x is 1 divided by y into dy by dx. The right-hand side is the product of two functions, log x and log of sin x. So we use the product rule to differentiate it. This gives the derivative of the right-hand side equal to log x into 1 divided by sin x into cos x plus 1 divided by x into log of sin x. Therefore, the derivative of y with respect to x is equal to y into log x into cot x plus 1 divided